Problem 4, what value of x will make this equation true? So we solve it by showing two sides of the equation. We want to isolate x on the left side to find out what it's equal to. Right now we're adding 12 to x, so we can undo that with the inverse operation, which is subtraction. Subtract 12. If I subtract 12 from the left side of the equation, I have to subtract 12 from the right side of the equation. I can't subtract 2 from 1, so I need to borrow here, making this 11. 11 minus 2 is 9. And this positive 12 minus 12, or 12 minus 12 equals 0, and that's why we did it in the first place, because we just want x on the left side of the equation. So x equals 9. We never finish without checking our work. The original equation was x plus 12 equals 21. So if x is truly 9, 9 plus 12 should equal 21, and 9 plus 12 does equal 21. So we know we did it right. Problem 5. The model below represents the equation 3x plus 2 equals 8. Let's make sure we agree with that first. We have 3 x's on the left side and 2 beans. So 3x and 2 beans is like 3x plus 2 equals, there are 8 on the right side, so that looks good. What is the first step in finding the value of x? Well, in order to find the value of x, we're going to need to do two things. We're going to need to take away these beans from the right side, from the left side, and also from the right side to keep the equation balanced. And then we're going to need to divide the 3 x's into 3 groups with x in each group, and we're going to need to divide the beans into 3 groups, and we'll find that x equals 2. But the question is asking us, what is the first step? The first thing we need to do is subtract 2 beans from each side of the equation. So that's answer choice B. Subtract 2 beans from each side of the model. Number 6, consider the model below. What equation is being represented by this model? We need to definitely take a close look at this key. The black squares equal -1, the white squares equal +1, and these white rectangles equal x. So we have 3 x's here and 2 black squares, so and is like plus. The 2 black squares are representing -1, 2 -1s, so that's -2. So 3x plus -2 equals, these are all white, so these are all positive. 3, 6, 9, 12, 13. 3x plus -2 equals 13. 3x plus -2 equals 13. Another good answer would be 3x minus 2 equals 13, because adding a -2 is the same as subtracting 2. So either one of these would be good. Okay, what value of x would make this model true? Let's do it 2 ways. We'll solve it with the model and with the equation. I can't take these 2 black squares off the left side. The reason I can't do that is because I have to do the same thing on the right side, and I don't have any black squares on the right side to subtract. However, I can get rid of these 2 black squares by adding 2 white squares to the left side, because each of these pairs is equal to 0. If I add 2 white squares to the left side, I have to add 2 white squares to the right side. And what we've done using the equation is we've added +2 to both sides. -2 plus 2, that's 0. So on the right side I have 15, and on the left side we just have 3x. And you can see that with the model as well. Now we know what 3x equals. 3x equals 15, but I want to know what 1x equals. So how many groups do I need? I need 3 groups. So I'm also going to group these squares into 3 equal groups. Each group has 5, so x equals 5. What we've done using the equation is we've divided both sides by 3. 3 over 3 is 1, so I just have 1x equals 15 divided by 3, which is 5. And we're going to check it by plugging it back in. 3x plus -2 equals 13. 3 times 5 plus -2 should equal 13. 3 times 5 is 15, plus -2 equals 13. Signs are different. We find the difference. 15 minus 2 is 13. We keep the sign of the integer that is farther from 0, and that's the positive integer. So positive 13 equals positive 13, and we check that x truly does equal 5. Okay, we'll pick up the review with problem 7 on the next video.